Aerial observation is structured viewing and documentation from an elevated or airborne perspective. Sources can include drones, crewed aircraft, towers, elevated cameras, and lawfully obtained satellite or other overhead imagery. The value of height is perspective. One view may show roads, structures, terrain, water, vegetation, movement, and relationships that are difficult to understand from the ground. That perspective can support inspection, mapping, emergency assessment, research, planning, and other legitimate purposes. Seeing, recording, interpreting, and reporting are different actions. A sensor captures a scene. A reviewer observes visible features. Analysis assigns possible meaning. A report communicates supported findings and uncertainty. Skipping these distinctions turns assumptions into apparent facts. Aerial imagery has limitations. Resolution, viewing angle, shadows, weather, vegetation, occlusion, compression, and time of capture affect what can be seen. A person, vehicle, or structure may be visible without revealing identity, ownership, intent, or cause. Every mission needs a lawful purpose and an accountable operator. Safety, aviation requirements, property access, privacy, data protection, and organizational policy shape where and how observation occurs. The objective is useful situational awareness and evidence, not uncontrolled surveillance. Collect only what the mission needs, preserve context, protect sensitive material, and avoid conclusions that the imagery cannot support. For example, documenting a washed-out access road requires a bounded route view and visible condition evidence. It does not require broad collection of neighboring homes, unrelated vehicles, or identifiable people. An observation mission should begin with a specific question. Examples include documenting construction progress, assessing storm damage, confirming whether a route is obstructed, or recording the condition of an authorized asset. The question determines the scene, detail, timing, and collection method. Define the area of interest precisely. A smaller bounded area reduces flight time, data volume, and privacy impact. Identify boundaries that should not be crossed or recorded, including nearby homes, sensitive facilities, people, or unrelated operations. Specify required detail. A broad overview may show access routes and terrain, while an inspection may require closer authorized views. More detail is not automatically better. It increases storage, processing, and the chance of capturing unnecessary sensitive information. Choose the relevant time window. Lighting, traffic, weather, vegetation, tides, work schedules, and temporary obstructions can change what is visible. The observation should occur when it can answer the question safely and without creating avoidable impact. Record environmental constraints and decision criteria. State what would make the data usable, what conditions would require rescheduling, and which uncertainties the imagery cannot resolve. Avoid redesigning the mission in flight without a renewed risk and privacy review. Also define what should not be collected. Purpose limitation protects people and improves analysis by reducing noise. A clear objective creates a defensible link between the mission, each image, and the final report. A useful objective also names the decision. If the audience must choose whether to send a ground inspection team, the imagery should support that choice instead of producing a general scenic survey. Planning connects the observation objective to a safe and lawful method. Review the location, applicable rules, airspace, property access, terrain, obstacles, people, nearby operations, and current official restrictions before selecting a route or platform. Weather and lighting affect both aircraft's safety and evidence quality. Wind, visibility, precipitation, temperature, glare, cloud cover, and shadows may change during the mission. Select conditions that fit equipment limitations and the analytical question. Identify a controlled launch and recovery area when using a drone. Plan battery margins for takeoff, collection, return, contingencies, and landing. Do not build a route that depends on ideal endurance or an uninterrupted communication link. Design a flight path or observation sequence that covers the authorized area with the required angle and overlap. Keep unnecessary private areas outside the frame where practical. Mark decision points for returning, landing, or ending collection. Prepare emergency options for changing weather, low battery, signal loss, people entering the area, navigation problems, or an unavailable recovery point. Brief crew communication and define who can call a stop. Document objective, location, crew, platform, permissions, official source checks, weather, lighting, hazards, controls, route, collection settings, and emergency actions. A written plan supports repeatability and later interpretation of the imagery. Review the plan immediately before collection because conditions can change. A route that was reasonable during desktop planning may become unsuitable when people, vehicles, glare, wind, or temporary activity appear. Still images preserve discrete moments with potentially high detail. Video captures movement and sequence, but creates more data and may reduce per frame clarity. Choose the format that answers the objective rather than recording both by default. Altitude and angle shape perspective. Higher views cover more area but usually show less detail. Oblique views reveal building sides and terrain shape, while near vertical views support plan style comparison. Angle also changes scale, occlusion, and apparent distance. Field of view is the area visible through the camera or sensor. Lens choice, altitude, orientation, and cropping affect coverage. Record enough context to locate the subject without collecting a wide area that the mission does not need. Overlap helps mapping and before and after comparison by ensuring adjacent views share features. Consistent orientation, route, altitude, and capture interval improve repeatability. However, repeated collections should remain within the authorized purpose. Stable capture matters. Sudden motion, vibration, poor focus, haze, glare, and aggressive camera movement can make footage unusable. Pause or repeat a safe capture rather than rushing through a checklist while conditions deteriorate. Review a sample for exposure, focus, framing, storage, and metadata when operationally safe. Clear imagery does not remove uncertainty, but poor imagery can create false detail and unreliable interpretation. Quality begins with deliberate collection. Collection teams should prefer a small set of well-documented, usable images over a large volume of rushed footage. Excess data increases review effort and can obscure the evidence that actually answers the objective. Scene reading begins with orientation. Identify image direction, scale, date, time, sensor, and location confidence. Locate stable reference features before examining change or movement. Without orientation, a plausible interpretation may belong to the wrong place or direction. Visible features may include roads, paths, buildings, vehicles, terrain, vegetation, water, construction, access routes, and hazards. Describe shape, position, count, condition, and relationship using neutral language before assigning meaning. Movement patterns can be observed in video or repeated frames, but they rarely establish motive. A stopped vehicle, gathered people, or changed route may have many explanations. Report the visible behavior and preserve alternatives. Shadows, roofs, trees, terrain, and perspective can hide features. Distance can compress space, while oblique angles can make objects overlap. Seasonal vegetation and temporary materials can change appearance without indicating a meaningful event. Separate observation from interpretation. An observation might be that water covers a marked section of road. An interpretation may be that the route is impassable. The second judgment may require depth, vehicle, ground, or official information not visible in the image. Use annotations and evidence references carefully. Mark the exact source frame and location, avoid covering important pixels, and distinguish confirmed features from tentative identifications. Honest limits make the observation more useful. Change analysis compares observations across time. Before and after imagery can support construction tracking, damage assessment, environmental review, route status, and event timelines. The images must be comparable enough that collection differences are not mistaken for scene changes. Repeat flights or observations should use consistent location, angle, altitude, lens, orientation, and coverage where safe and lawful. Record deviations because a shifted viewpoint can reveal or hide features and alter apparent size. Seasonal differences matter. Leaf cover, snow, water level, crop state, and ground color may change normally. Lighting and shadow direction vary with time and weather. These effects can resemble damage, removal, or new objects. For construction or damage assessment, define measurable features before comparison. Record visible additions, removals, displacement, surface change, axis change, or debris. Avoid assigning cause or severity beyond what the imagery supports. Preserve event chronology. Distinguish capture time, file time, upload time, processing time, and report time. Metadata can help, but may be missing or incorrect, so corroborate important timing with flight logs and other records. A useful comparison explains what changed, what remained stable, how collection conditions differed, and how confident the judgment is. It also states what ground inspection or independent evidence is needed. Observation data should remain connected to mission context. Use consistent file names that include a date, mission identifier, platform or sensor, and sequence. Avoid generic names that lose meaning after files move. Preserve available metadata such as capture time, location, altitude estimate, orientation, device, and camera settings when the mission requires it. Metadata is useful context but can be incomplete, altered, or imprecise, so it should not be treated as absolute proof. Flight logs and source notes should record objective, crew, equipment, route, weather, lighting, settings, deviations, and significant events. Map references link images to the area of interest and help reviewers understand coverage and gaps. Protect original imagery from accidental editing. Store working copies, annotations, crops, and processed products separately and document transformations. Every observation in a report should point to the relevant original or control derivative. Storage and access should reflect sensitivity. Imagery may reveal private property, people, infrastructure, or operational details. Use approved encrypted storage and transfer where appropriate, restrict access, and log significant exports. Retention should match mission, policy, legal, and evidentiary needs. Remove unnecessary data through approved processes when the retention period ends. Good documentation makes analysis repeatable without turning a limited mission into an indefinite surveillance archive. Aerial perspective can reveal people, homes, routines, property, sensitive locations, and security features that were not the mission's purpose. Public visibility from above does not remove privacy expectations or the risk created by recording, aggregation, and distribution. Apply data minimization before launch. Bound the area, aim sensors carefully, choose no more detail than needed, and avoid unnecessary people or private spaces. If sensitive content is captured incidentally, restrict access and follow approved review and deletion procedures. Use requires legitimate authority and proportionality. Do not use aerial observation for stalking, harassment, targeting private individuals, unlawful surveillance, flight restriction bypass, interference with aircraft, or evasion of accountable oversight. Reporting can create harm even when collection was lawful. Avoid publishing precise sensitive locations, identifiable people, access vulnerabilities, or raw imagery without a defined need. Use redaction, aggregation, or controlled distribution when appropriate. Access control should separate pilots, analysts, clients, administrators, and public recipients according to need. Protect accounts, storage, exports, and sharing links. Record who approved collection and who received sensitive products. Responsible use is explainable. The operator should be able to state the purpose, authority, boundaries, evidence, uncertainty, retention, and safeguards. When safety, legality, privacy, or ethics are unclear, stop and seek qualified guidance. Aerial observation is structured, purpose-driven visual collection from above. It can use drones, aircraft, towers, elevated cameras, or overhead imagery, but every method requires context, authority, and careful interpretation. Begin with a question, bounded area, required detail, time window, environmental constraints, and explicit exclusions. Plan rules, airspace, property access, weather, lighting, obstacles, route, battery margins, recovery, and emergency options. Collect stable, well-framed imagery with an angle, field of view, overlap, and format suited to the objective. Describe visible features before interpreting them, and never infer identity, intent, ownership, cause, or severity without supporting evidence. Time-based comparison depends on repeatable collection and preserved date, location, sensor, and condition context. File naming, metadata, logs, source notes, controlled originals, access restrictions, and retention make findings reviewable. The goal is useful situational awareness and evidence, not uncontrolled surveillance or instant certainty. Strong practice combines safety, image quality, documentation, privacy, proportionality, and responsible reporting.